This program will focus on the basic principles of washing. Although washing equipment and devices differ at each institution, the basic premises can be utilized in any healthcare or scientific setting. Cleaning seems to be the bane of our existence. It's part of our daily routine and reflects in part our lifestyle. Our perceptions regarding what is truly clean differ from one person to another. These different perceptions are often influenced in part by what we're cleaning and how we perceive its value. That's what makes cleanliness so hard to define. That's also what makes it so important. Cleaning is defined as the removal of soil containing microorganisms or inorganic debris adherent to surfaces by a process such as washing with water and detergent. We can see by this definition that the tasks of cleaning and or washing in this case have two main functions, non-microbial and microbial. The non-microbial functions are to restore or improve the appearance of something, to eliminate non-organic traces, to maintain its functioning, or to prevent its deterioration. In areas of healthcare and in laboratory or scientific research specialties, aesthetic appearance, or the non-microbial function of cleaning, is combined with the microbial function. In the microbial function, items are cleaned or washed to decrease their bioload or bioburden. By washing away harmful organisms in an appropriate manner, we decrease their numbers and potential to harm. Since microorganisms can't be seen with the naked eye, good washing practices help ensure that the items we use in our daily lives or work are safe to handle. There are two types of washing: manual, which is often referred to as hand washing, and mechanical. Types of mechanical washing systems include dishwashers, washer sterilizers, washer sanitizers, and washer disinfectors. Some types of washers are even specific for the types of the devices being used. These include utensil, glassware, cage and rack, cage and bottle, tunnel cage, and cart washers. In either case, manual or mechanical cleaning will utilize three types of energy. They include chemical, or use of some type of detergent, thermal, referring to a specific temperature, and mechanical action, the use of old-fashioned elbow grease or multi-directional reciprocating spray arms. Regardless of the type of surfaces we wash, skin, equipment, glassware, cages, or environmental surfaces, the components involved in the washing process remain the same. Knowing about these components and how to use them appropriately and properly will enable you to clean more efficiently and effectively. The principles of washing include a working knowledge of the type and amount of soil involved, the quality of the water being used, the type, concentration, and pH of detergents that will be applied, the device being cleaned, the type of mechanical action to be used, and the contact and coverage times. Coverage is a key principle. It's important to deliver water to all surfaces of the load to achieve maximum cleaning. But all these factors will influence the efficacy of the washing process system you select. So let's review them individually. Probably one of the most important factors is the type and amount of soil present on the device you're attempting to clean. After ascertaining the manufacturer's recommendations regarding the appropriate method for cleaning of the device or equipment, one should pre-sort them into two main categories dependent on the types of soil to be removed. Soil is usually classified as either organic or inorganic. Oily fats and greases, along with protein derived from blood and other types of bodily fluids, are considered organic and constitute the majority of and the most common type of soil seen in healthcare facilities and research laboratories. Inorganic soil is usually composed of mineral deposits such as urine scale, calcium, magnesium, or iron. Traces of these types of soils are often found in animal research, industrial, chemical, or pharmaceutical operations. The amount of soil is usually referred to as light, medium, or heavy. The amount of soil dictates what will need to be pre-washed and the length of time required. After visual inspection, grossly soiled items can be manually hand washed by immersion in water and detergent, or mechanically pre-washed by using the pre-wash cycle if provided on the washing equipment. In the case of mechanical washers, items covered with grease and minerals are usually pre-washed in hot water. When soil is composed of protein or glucose, cold water is the preferable treatment of choice for the pre-wash cycle. Temperature is another factor that influences the other components in the washing process. The rate of disinfection is accelerated with increases in temperature. This is important when considering applications of detergents to various types of tempered surfaces. Heat enhances the separation of soil from articles by increasing the reaction rate between detergent and soil. Also, it's important to note that some bacteria are destroyed more rapidly by a modest increase in temperature. When utilizing a mechanical washer, temperatures are often determined by the manufacturer of the equipment based on research testing. However, in most cases, the operator can select the proper water temperature. Optimum temperatures vary in relation to the types of soil being processed, the type of device being processed, and the detergent needed to cleanse the device. Optimum wash temperature ranges are between 150 degrees to 170 degrees Fahrenheit, with minimal and maximal acceptable ranges occurring between 140 degrees to 180 degrees Fahrenheit. For example, many in the animal care community recognize 180 degrees Fahrenheit for 3 minutes as the industry standard to achieve sanitization. Cycle times also vary in relation to temperature and amount of soil. Shortest cycle times usually range from 1 to 4 minutes to longer cycles reaching 5 to 9 minutes. In all cases, the appropriate cycle and temperature setting should be determined by checking with the manufacturer of the device or labware being cleaned and the washing equipment being used in order to promote the greatest efficacy and safety. The amount and type of soil not only impacts the time and temperature parameters of the washing cycle, but also influences what type of detergent will be needed to enhance the cleaning function. It is probably no exaggeration of fact to state that there is no one detergent best suited for use in a manual or mechanical washing process under any or all conditions. The principal function of a detergent is to render surfaces wettable so proper cleaning and contact can occur. Sounds easy, doesn't it? But really, it's a complex process by which the appropriately selected detergent compound, by virtue of its chemical and physical properties, lowers the surface tension of the water, allowing for better contact of the water with the device being washed. This union assists with the solubilization of albuminous soil, increases the emulsification of oils, and suspends the soil particulate in the solution where it can be taken away. An easier way to describe the function of detergents is to say they break down organic soils such as proteins in blood and/or suspend inorganic soils such as urine scale so proper contact and coverage can occur to enhance cleaning. Detergents can be classified as either highly alkaline, moderately alkaline, neutral, or acidic cleaners. These classifications are determined by a pH scale and relate to the number of hydrogen ions occurring in the detergent's composition. The pH scale is a logarithmic function rather than a linear function. Although the scale ranges from 0 to 14, it takes on a V-shaped appearance, with 0 being highly acidic, 7 being considered neutral, and 14 being the highest alkaline. The highly alkaline detergents usually contain potassium or sodium hydroxide or a type of caustic soda as the primary active ingredient for dissolving power, to which is added sodium metasilicate as a corrosion inhibitor and water softener. Usually, other agents are added to prevent calcium or magnesium salts from precipitating out when the detergent is used in hard water. A wetting agent or surfactant is also added to increase coverage. As a general rule, the highly alkaline detergents possess rapid dissolving power for proteinaceous and emulsifying fats and oils. The moderately alkaline cleaners are of a different composition. Phosphates are not usually recommended and are not added to many detergents due to their environmental impact. The moderately alkaline detergents are the most satisfactory for general cleaning. They are less corrosive than the higher alkaline detergents, but may attack aluminum and ground glass surfaces also. The neutral cleaners are those products which, when used in a solution, develop a pH close to neutrality. These are commonly found in synthetic household detergents. Acidic detergents operate in the pH scale range substantially below 7.0. They incorporate a mild organic acid to which is added a wetting agent. The acid detergents exhibit low foaming properties, which are important when using mechanical washing systems. In general, the nature of the soil determines the selection of detergent for the washing process. Animal urine scale is removed effectively from cages with an acid detergent. Soil considered to be acidic in nature, such as protein or food substances, need an alkaline reaction to neutralize it. So therefore, an alkaline detergent should be used in those cases. On the other hand, soil rated as alkaline, such as urine scale, needs an acidic reaction to neutralize it. So an acidic or low pH detergent would be the most advantageous in those situations. Knowledge of forces involved in the deposition and binding of soils on contact surfaces and how best to clean them is highly technical and often causes conflicts when attempting to clean many different types of devices at the same time. The best insurance against mishandling of equipment and devices is to pre-sort devices prior to cleaning and to then check with the manufacturers of the products for washing instructions prior to using them in your department. Washers that offer multiple accessory manifolds can accommodate multiple types of baskets and glassware, thus reducing load accumulation and increasing cleaning throughput. Water is the universal cleaning agent, and an adequate supply of water is the strongest weapon in removing soil. Water serves as the medium for carrying the detergent to all the surfaces of the load, aiding not only in coverage, but after contact, removing the separated soil. Unfortunately, not all water sources are suitable for use in washing systems. Pure water is a rare commodity in nature. When formed in clouds, it is in a relatively pure state. But its composition often changes when returned to Earth in the form of precipitation. Alteration of the water occurs due to contact with air pollutants or mineral substances in the soil. The precipitation absorbs minerals from the soil, causing the phenomena of water hardness. Total hardness of water means a characteristic generally accepted to represent the total concentration of calcium and magnesium ions present in the water. Water hardness is usually represented in parts per million of the equivalent amount of calcium carbonate, as well as other ions. Hardness of water varies by locality. Because of this, certain areas of the country must prepare the water or soften it prior to use for the washing process. Water hardness will often determine the amount of detergent concentration needed. In most cases, the harder the water, the more detergent it takes to cleanse the load and remove unsightly organic deposits at the end of the cycle. Now that we've discussed the components of the washing process, let's begin to review the steps involved in cleaning. They are sorting, pre-washing, washing, rinsing, and drying. Dried-on soil presents a difficult challenge to any type of cleaning, be it manual or mechanical. Good results can only be expected when the devices are washed promptly after use. In cases where this is not possible, the load should be kept moist and covered to prevent drying and cross-contamination. Pre-sorting of the load, keeping in mind the principles of washing, can not only expedite the washing process, but also improve its efficiency. Pre-washing of grossly soiled devices with water can remove a high percentage of soil from the device. This action is obviously enhanced by the factor of mechanical action and coverage when correctly applied either manually or when used in the selected mechanical washer. The purpose of pre-washing is to prepare the load for proper washing and to saturate the soil for efficient cleaning. When using a mechanical washer, the fundamental rule in loading is to arrange the devices in such a manner as to allow for appropriate coverage of water from the spray arms. All devices such as flasks, beakers, test tubes, and graduated cylinders should be used with the appropriate accessories. Using the proper accessory is essential to cleaning efficacy. Specialized accessories are available for different types of glassware, utensils, cages and racks, and instrumentation. Manifold systems with individual spray jet spindles assure thorough internal cleaning. Baskets or trays to hold small objects or instruments should be properly sized to contain the load, but also to provide adequate exposure and surface coverage to the load. Accessory baskets should have holes large enough to allow for adequate coverage of turbulent water, but also to assist in drainage after the washing cycles are complete. Loading should occur from the bottom up, while adding appropriate shelves or accessories above each layer as determined by the manufacturer. If some items are higher than others, they can be placed on one half of the chamber, leaving space above for other items as long as appropriate coverage and draining occurs. Remember, in all circumstances, complete water coverage of the load takes precedence over mechanical action. Manual or mechanical washing cannot clean surfaces they cannot contact. Flanged or curved items such as glassware should be placed with their opening down on individual spindles. Metal objects such as basins should not be allowed to trap water or be stacked in an effort to conserve space. Edges of devices should not be touching to facilitate free access of the cleaning solution. Devices should be checked and placed in the chamber to assure free access of the spray arms. Adequate room between the load and the access door should be provided to allow for easy door closure, visual inspection of the load during the washing cycle, and comfortable removal. The washing process is accomplished by means of a vigorously agitated detergent bath that helps in the removal of soil necessary for proper cleaning. The combination of high-velocity jet streams of water supplied by unidirectional or multidirectional spray arms develop the proper water turbulence. It should be noted that water sprayed at a high velocity does not always equate to complete coverage. Water must be allowed to cascade down the glassware. Very high-velocity water can lead to glassware breakage. The agitated detergent solution disengages blood, grease, tissue, and other foreign substances from the load and carries the soils to the surface and away from the devices. The released soil and residue overflow are then pumped out of the chamber. There are usually 5 different phases employed in mechanical washing cycle. They are the pre-wash cycle, the wash phase, an initial rinse, which is usually the same temperature as the washing phase to remove detergent, and a final rinse. The final rinse is essentially an insurance policy in conjunction with the first rinse for removal of residual soil. And in some types of mechanical washing systems, provides a sanitization or disinfection function if the appropriate temperature is maintained for the proper time. The final rinse, which is optional on many mechanical washing systems, can be a pure water rinse. Pure water provides the opportunity to remove trace minerals left over from the tap water and helps to prevent the possibility of staining or spotting in the load. If the mechanical washer has a drying cycle, the load should be allowed to cool down properly before it's removed from the chamber. Care should be taken when opening the access door in case of steam vapor being emitted. An unloading cart that fits snugly and securely parallel to the opening of the access door of the washing chamber should be utilized to avoid back strain and injury. Items should be allowed to sit and acclimate until they're completely cool in an environment that's at a similar temperature to discourage recondensation on the load. All personnel operating the equipment must receive proper in-service training regarding equipment operation, safety applications, policies and procedures for use prior to running the equipment. It should be the routine duty of personnel in the department to clean the interior of the washer on a timely basis to remove any residue or scaling caused by the washing process. Spray arm and manifold nozzles should be checked for clearance and clogging. All filter screens should be removed and cleaned daily. Detergent levels should be monitored. The exterior cabinet should be cleaned as needed. If the system has an alarm, all lights and sounding mechanisms must be checked regularly. Finally, let's review the proper environment and attire for the appropriate care and handling of items during the cleaning process. Ideally, the soiled preparation area should be in a room separated by a wall from the clean work areas. If that isn't possible, be sure to utilize good work practices to avoid cross-contamination of soiled and clean workstations in a common room. Ventilation in this area should be controlled. Fans should not be used since they cause dispersion of possible pathogenic particulate matter into the area, increasing the concern for workers' safety and providing a continued medium for bacterial growth on work and device surfaces. The temperature should be controlled at a comfortable level for personnel working in the area. Good general lighting is essential for safe working conditions, but should also be placed strategically in areas requiring close inspection and visual accuracy, such as in areas where the completed cleansed devices can be scrutinized for cleansing efficacy before distribution and/or assembly. Finally, traffic in and out of the area should be controlled and restricted to personnel working in the area. Personnel should wear a clean uniform or cover garment to protect their outside clothing from damage and/or contamination. Hair should be covered and feet should be protected in some type of protective fluid-resistant boot, either single-use or reusable. Protective eyewear must be worn to avoid splashback or foreign material entering the eyes during washing. Also, if the items are contaminated with human blood and/or body fluids, a high filtration effective surgical type face mask and gloves should be worn. Be sure to review any warning statements on the detergents being used. A good rule to follow is to avoid any direct contact with the skin, eyes, and mouth when using cleaning compounds. Proper personal hygiene must be encouraged. Hands should be washed routinely, utilizing an appropriate skin antiseptic before donning and after removing gloves. Gloves of a proper thickness should be worn when handling contaminated devices and when removing them from the washer to avoid skin punctures. Jewelry should not be permitted. Jewelry could become caught on items being cleaned and cause injury to the personnel wearing them. Nail polish should not be worn since it could not only chip and fall into cleansed devices, but it could also mask harmful soil underneath nails. In summary, this presentation today has given you an opportunity to review appropriate and safe work practices for your facility to enhance your productivity during the washing process. Proper cleaning is the first step in the decontamination process. Knowledge of the principles and techniques associated with the washing process can enhance your current quality assurance standards. How clean is clean? Currently, tests are available to you through the manufacturers of products and equipment to help you answer this question and any others you might have. Use them as a resource. Proper standards of care during the washing process are crucial for cleaning efficacy to occur. Cleaning under any circumstances is an important job. Good luck and good washing.